Okay, now we are doing part 3 of lesson 6.2. Now let's construct an exponential function when given 2 points. So this is a little bit different. So we have these points here, 312, 424. Let's talk about some of the things that we know here. First of all, when you're looking at functions, the y values, those are outputs. So that's what f of x would equal. F of x could equal 12, f of x could equal 24. These are x values, which means positions. So this means this is the third term in the sequence. This is the fourth term in the sequence. So if we're writing a function, we've got f of x equals our format of a b to the x power. So step 1, let's find b in this case. And we can do that, find b by taking 24 and dividing it by 12, which will equal 2. These are y values. And this position comes after this one, so we put it on top. Now we have the common ratio. So that means now we know that f of x will equal a times 2 to the x power. All right, so what can we do from here? Let's go to step 2. Step 2, now take 1 point plug it in to that equation. So I'm going to use this point here, the 312. So I know that 12 equals a, which is our first position, which we don't know, times 2, because that's what b is, to the third power, because that's the x value. So that means we have 12 is equal to a times 8. Okay, 2 cubed is 8. Now all I have to do is divide 12 by 8, and I get 1.5 is equal to a, which is the same as 3/2. So third step is now to write the full function. F of x equals 3/2, or 1.5 if you want to do it that way. It is a terminating decimal. And there's our function that would model this relationship, right? All right, let's try another one. Now, this next one's a little different. So again, we have 2 points, 4, -5, 1, -3. Now, the problem we have here, in the last problem, we had 2 points that came right after each other, position 3, position 4. This time we don't. We've got position 4, we've got position 1, so we need to go at this a little bit differently. We can still start with a basic function, so I'm going to choose this first point. So I know that y, or f of x, is -5, and that is going to be equal to a times b, and in this case it's to the 4th power, because I know that x value is 4. So I know that. Now I can rearrange this equation. I'm going to divide both sides by b to the 4th. So here it's going to cancel, okay? And so now I've got -5 over b to the 4th power equals a. Now I'm going to set up the same equation, but for this other point, I know that -3 is equal to a times b to the 1st power. What can I do with this? Well, back here, I rearrange this equation so that -5 over b to the 4th equals a. I can now substitute that in to this equation, which means I will have -3 is equal to -5 over b to the 4th times b, or b to the 1st, Okay. What's going to happen here? We're going to get some reducing. This is going to go away. This is just going to become 1. This is going to become b to the 0. And this is going to become b to the third. So now we have -3 equals -5 over b to the third. I can now multiply both sides of the equation by b to the third. So I'll have -3 b to the third equals -5. And now I can divide both sides of the equation by -3. So b cubed equals 5/3, because -5 divided by -3 is going to be just positive 5/3. And then all I need to do is take the cube root, since it's cube root of 5 to the third. So b is going to equal roughly 1.19. And now I can, back in my original equation where I had here, a equals, so a equals -5 over 1.19 to the 4th power. A is going to equal -2.5. So my function, f of x or y or whatever you want to call it, we'll just call it y this time, change it up, y equals -2.5 times 1.19 to the x power. Okay? All right, let's apply this now to a couple of story problems. Example, John has $160 after saving for 4 months. What does that mean? That is a point. 4 months, $160. He has $640 a month later. So we know that's month 5. He's got $640. Write a function to describe this exponential growth. Again, we can do it a lot like the first problem, or we can do it like the second problem. I'm going to do it like the second problem. So I have 160 equals a times b to the 4th. I'm going to rearrange that. A is going to be equal to 160 over b to the 4th. And then I have my other equation, 640 equals a times b to the 5th. Now I can do some substituting. 640 equals 160 over b to the 4th times b to the 5th, which is going to reduce quite nicely into 640 equal to 160b. Now I can just divide both sides by 160. B is going to equal 4. Now I can put that back into my original equation. A equals 160 over 4 to the 4th. And I get A is equal to 0.625. So then my equation would be y equals 0.625 times 4 to the x power. Okay? Here's another one. You have water in a container sitting in the Arizona sun. After 3 hours, you have 768 ounces. An hour later, you have 614.4 ounces. How much water did you start with at time 0? Again, we've got a couple of points. So at the 3 hour mark, got 768. And then an hour later, so that's the 4 hour mark, got 614.4. And now I'm going to try doing it the way we did the first problem, which is I'm just going to straight up find B, which will be 614.4 over 768. That's going to give me 0.8 for B. And then I can say f of x could be equal to A times 0.8 to the x power. I'll put 768 in there, equal to A times 0.8 to, well, when it was 768, it was 3, so it's to the third power. You can solve there. A is going to equal 1,500. So that is my original amount. And then if I want to write it as a function, f of x equals 1,500 times 0.8 to the x power. And that's how we can use data that we have to actually write an exponential function.